Okay. Hello everyone. Welcome to our week 4. Like, how are you guys doing? Hopefully you can get like all the exams A and get all the quizzes, homeworks A. Oh, like hopefully nothing changed. You're doing very well. And today we're happy uh having the lecture 4, control statements. So the C++ conversion is covered in Computer Science 110. I guess it's basically roughly this week's. We may have 2 weeks completing while loop and also if statements. Yeah. So um, So our study goal for this lecture is how to make decisions using a program, like making decision involving if statements, and then what is an iteration, and what is a conditional iteration. Okay. So making decisions. Making decisions involved in resolving problems due to different situations. Like we have many cases out there, and then you have to find a solution for every case, kind of like given a situation. So in real life example, like is that like when I go to grocery, if I get more than 100 bucks, I'll buy beef. Yeah, I know you have some vegetarians there. I'm sorry, but it's kind of like that. Like if I have much money, I can buy the most expensive stuff. And if not, if I get like roughly 75, I get greater than 50, I buy pork. And else, oh, I'm poor, I buy chicken though. Like another example is like, oh, when I go to school, which is like only within 1 mile, I walk there. Or if not, I would just like, if it's less than 5 miles, I may take a bus. Or if there's greater than 5 miles, like else cases, I may take a Uber. Yeah, I may take a subway. And we use if statements to choose and or filter out like some operations due to corresponding conditions. Like we'll have different operations on every case. So it sounds like if A, okay, then B. If not, else if it's C, so then I will get D. And for the default case, just else E. Yeah. So this is kind of like roughly, literally going to explain about what if statement does, and we'll have an example of this, like define final grade. It's like when you take your math class and then you see, oh, what's my final grade? I get 99. Oh, maybe it's 100, roughly round 2. So this is the if statement. We have if, else if, and else. And so for the format here, we have wait. So format here, we have if keyword, and then we have a bunch of things. We call this condition, and then we have a column. And this thing is the body of the if statement. Yeah. So we have is, if else keyword, and we have also conditions, and also a column. So how to know if we hit the if statement and then run things inside the if statement? You see, if parent, like if the parameter, if the things of the if statement returns a true value, and then it will go into the if statement and then run them. And um, else you just skip them. So the function jumps into the statement and then to run body, the main body, and then finally, like maybe you have something else in if statement, but once you hit the return statement means return and then stop. Like we're actually running the code inside the frame, inside the frame of the function, inside the frame created by this function. And then once we hit the return statement, we'll return the value to where the function is called. And then we will end the frame, like we will end the function running and then return to where the function is called. So return statement means stop, like it stops the function from running, from continuing running. Okay. So we have else if and else case. So else if and else is like alternative option of the if statement. Like for example, when I jump into this if statement case and I will run off this, and then if I do not have the return, I may continue running and we run OC. Oh, I have else if and else, but I already satisfies one of the if statements ahead of them. So I do not have to, I do not jump into them. They are only for like basically you can choose either this or that. Like you can have both. So this is else and else if. And especially for else else is like the default. Like when I do not satisfy, um, if none of the conditions can be satisfied, then I will jump into else, like just for all the remaining cases. And then I'll have a demonstration of it. Yeah, turn off. So we have Python tutor, our best friend, and let's see. Like if I call final grade and I pass 89 into the function, let's see. So is so let's run it. So if grade is greater or equal to 90, no, like it's 89, is less than 90. So just jump this. So, okay, we have else if grade is less or equal to 10. Yeah, so 89 is way larger than 10. So I return 10. Just return, oh, wait. Oh, sorry for that. Oh, grade is less or equal to 10. So 89 is bigger than 10. So obviously does not apply. So else just return grade. So if I modify a little bit, like let's see, if I have 101, so 101 is like it's greater than 90. So we jump into this if statement, and then grade will be 102. Let's see, like the number changed here, so we just return 100. Yeah, so we end the function. We end the function. Okay, so yeah. Any questions, comments, concerns about making decisions part? Yeah, it's like only one of the samples will cover other like different models then. Okay. Yeah, you can either type on the checkbox or just like turn on your mic and talk to me. Okay. Um, now I have four models of if statements and like they might be the same, but some of them are different from than others. So let's jump into it. So if else if return model is like whenever um whenever I jump into the function and I satisfy either one of it, I will jump into the if statement, and then I'll see, oh, we have return statements nested in every if conditions, like every situation. And then I just hit the return, and we end the function. We don't actually have to look into them. So it's like the model is like, oh, I satisfy them, and it goes go in if, and then I hit the return. Like return means stop the function. So which means whatever the things what is shit written down there, I don't actually have to look into that because um return means stop. So we stop the function and we don't have to look into like the remaining part of it, and then just exit the function. Okay. So this is the example we just made like for our first one. That one is evasive return model. Okay. So next one is if return. If return is like, oh, I have returned if, and then I'll just still hit the return statement. So I hit if, and I just return an X, like no matter what, like you see, oh, there's an if, but I still have to return it to see it, no, because return statement ends the function. Like it means stop. Like when like you are driving, like it has stop sign, you have to stop and stop it from running. Okay, so basically else if return and out and if else if return and if return they are the same thing. Like although we have if else if like basically is kind of like extra stuff. They are the same because once you hit the return statement, you return and you end the function. Okay. So the next thing is if else if. If else if is like when I um, when I go into the function, uh, it just like if I satisfy it, I run it, or else I would, or if not, if I do not satisfy with this condition, I will just jump into another one to see, oh, else if, and I satisfy with it, and then I run it. And after I run it, I don't actually look into other cases because we have the else if. Like if you satisfy either of the conditions ahead of the else if statement, like it would not jump into the else if, or it would not to evaluate the condition of else if statement, because you can only take one. Yeah, if none of them apply to you, just skip to else. But notice that like when I run all of the else, I do not exit the function because I did not like hit the return statement, or I did not go to the end of the function. So which means that I'm still running into the stuff until I hit the return statement. So the model is like, if I hit this, and then I will finish the part of the if statement, and then I will not see all of them. And then I will just go to the remaining part of the function. Like notice that we don't actually run into the remaining part of the function because we already have a return statement in our if statement. So which is very different. You still don't forget the remaining part of the function, and then when you hit the return statement, you exit. So a fast example of this. So so oh, I see. We still have a function call. See, 120. Okay. So you get if s is greater than 100. Yeah, so I just run into a -1. Okay, so and then I will skip up then, but I still have to run the remaining part of the body function. So just run and then return. Yeah. So yeah. Okay. Yeah. Can you actually know about how that works? I think so. Finally, we have the if model, like which is that often if and no else if. So that means if I pass in a value and if I satisfy this condition, I'll run it, but I'm still going back to see if I have to check because it's not else if, it's not else if. So I'll still check other if statements because for a single if statement, if some if statements ahead of it already satisfied, you still have to look into the if statement to see if the condition is satisfied, and then you still have to run it if it's satisfied. You still skip the else, but yeah, you still have to run into it, and then you go to return. So it's like you have if, then you finish the part, you go back to check another if. So, okay, if I satisfy, so just go, you skip the else. If you none of the condition apply to you, you skip the else. But if they both satisfy, you have to go for all of them, and then you go to the remaining part of the body, and then you exit the function. Yeah. So, any comments, questions about it? Yeah. Mm-hmm. Okay. So, is else statement necessary in codes? Like sometimes you don't actually have to have else. Like it may make your code more understandable, but like for the coding function, it actually depends, yes or no. So if you say no, you may want to like make only some additional changes on only some specific variables or some specific conditions. Like for example, if you have even an odd number, you only want to make a change on even number and remain the same of the odd number. You say if something like if it's even, and then I make a change, or and that's it. You don't actually have to, but maybe you can have that too. It doesn't affect. It makes your code more understandable. But yeah, if you don't have the else, it works the same. But maybe yes, if you want to make change on all the variables, but I want to make different changes due to each different condition, different case. Like for example, I want to add one to odd number, and I want to add two on the even number. So it will be different. Yeah. Okay. So let's have a like kind of 5 minute practice to see what are all the outputs of the function. So it is 1, 2, 3, 4. So we have 4 functions, and let's see if you can find out what value it will return if I pass in 89. Yeah, and you type your answer in the order 1, 2, 3, 4 on the chat box. Let's have 5 minutes to do that. Yeah. Okay. I remember we have all 4 kinds of models here. So let's see. Like 3 of the answers are same, and there's only one different from the others. Actually, see this. Actually, see this still return. Oh, okay. Here's a return, an necessary return statement. Okay, you have your answer. Mm, okay. Oh, check your answer again. Like my suggestion, like I said that like 3 of the answers will be the same, and this one different from others. So, mhm. Okay, yeah, because there's a bar there, like my taskbar. Uh, it has a hidden return. Okay, I think we can have what the answers are. Actually, Tianyan's answer is correct after his correction. So we have we have 100 for the first case, and for the second one we have 105. First one we have 100, and the fourth one we have 100 as well. Okay, so 1, 2, 3, 4. Yeah. So why is that? Let's check each of them. So you have 89, you pass into 89 for case one, and you have, if grade is greater than 85, it is, so just return and you don't have to look into all of them. Yeah, so this is 100. For the second one, is 89, so if grade is greater than 85, the grade is 100. So temporarily now the grade is changed to into 100. And for the next, it's not else if, it's only a single if. It will still check the condition if it's satisfied. But it is satisfied, so you just still run this, and then you add 5 into 100. So you will return 105. Yeah. For the third one, we have 89 passed into it, and if grade is greater or equal to 85, yes, so grade is 100. And then you just change to 100, then you skip all of them because I already satisfied with the first condition, and then you return grade. You return 100. So for the fourth one, if grade is greater than 85, you hit the return statement. So you just have 100. So this is 100. All right. Um, yeah, congratulations if you had that correctly. And yeah, if you're not, it's okay. You can still like realize what's happening out there. If you still have something confused you, um you just said to me. Yeah, just talk to me and just type on the chat box. Okay. Maybe you have like I don't know if I have to run that. I have this. Mm, yeah, I don't think so. I just send to you and then you can run that. Yeah. So then we'll go into iteration. The one of the most exciting part of the uh, coding class. So what is an iteration? Iteration is there are some parts of the code that can be run by the program more than one time. Like maybe it will be 2 times, 20 times, 200 times, 2000 times, whatever. Um, yeah, so it has the capability to run more than one time for that part of the code. And for this part of the code, we call that a loop. A loop is like a circle or a roundabout. Like you go into it, you just circle it many, many times until you want to live. Yeah. And how many kinds of iterations are there? Mm, I'm not sure if that's actually 2 or 3, but as far as I've learned, for Python, we only have while or for loop. We have C++, we have do while. Um, yeah, so while loop is the topic which we will going to talk about from the next slide. And it's a conditional loop. So that means that you can actually control the while loop easily. Like you can set a condition, like when you end the function, like I want to end the loop and set a condition to that, like to your condition, and then you can just end it. But for loop, it's unconditional. Like it's actually uncontrollable. It's hard to control. Uh, we'll talk about that like maybe after a month or something. Um, it's basically like to be simple. It's basically you have a bunch of data and you want to grow through all of them. Um, so you can easily control like while is when something happens and you cannot end the loop unless you have the return statement. Um, yeah. So what problems can be solved with iteration? First thing is like rearrange data order, such as I give you a bunch of data and then you sort it in ascending order, means that you go from 0 to 100, from small to big, or maybe descendingly from 100 to 0. Yeah, and then you search for some specific things. It's just like, for example, I want to look for a formula in my math book, and I'll say, oh, it's an integration formula. I'll check it with the first one. No, if not, I'll check the second one, and etc. etc. Yeah, until I hit the one I want to. It's basically the same thing. Like it's basically like if I hit something, it's the same as what I want to look for. I'll just return. Yeah, and filter out. Like take out some number from like some data, like the data you don't want to, and then you modify the data with some similar, like for example, I want to add one to a variable many times. Yeah, okay. So usually you call the code using iteration a loop. It's a roundabout, like you want to enter that loop again and again until you want to return. Like want to exit, just exit. Yeah. So while loop is a conditional loop. So this is example of a while loop. Like you may know what the function is actually do. I will show you later. Yeah, again you can guess. So for the while loop, this is the part of the loop we're going to talk about. And when you hit the a equals n minus one, you get a what a is, and then you just go into the while loop and you loop it. Yeah. So the part um, for here is the body of the loop. So this part of code, oh, uh, uh, including a plus, including a minus equal to one. So for this part of code, we call that the we can say like it's the body of the while loop. Yeah, we will actually looping through, like executing the code again and again until some condition ends. So the format is the while. So while keyword, and this is where the condition is. So for here, condition is a greater than 0, and then we have the body. And for the last line, or maybe not the last line, but there will be some line between the body that like you actually want to narrow it down. Okay, so this is condition. Then you hit the loop. You just to see if the condition is satisfied. If it's not satisfied, you just skip the whole thing. The same as an if statement. Or if not, I will run into the all the part of the code. I will like run the body of the loop, and then I will go to the end of the loop, and then I will still return to see, oh, if maybe the condition is renewed, maybe a condition has changed. So I will just compare if the condition still satisfies with my situation, still satisfies with the condition shown here. And if yes, I'll still run it and run it again. If not, I will just still I I will leave the loop and then go to execute the remaining part of the body, the function. Um, so this is how while loop works. Yeah. So the format of it is just while and your condition and then the body. Yeah. So this is when you hit the while, you have the while keyword and have the condition, and you just skip it if it returns the false value, same as the if statement. And if not, you will run into the function body, and then you have the column. Yeah. Okay. And then when you start running the code, you just go for uh, all the body of the loop. Then maybe you narrow down the while loop, you execute the function body, and then if there's a return statement inside of the function, inside of the loop, sorry, you will still return and end the loop, also end the function execution. Like maybe like that's the only way you want to end all the loops, including for loop. Yeah. So when you hit the return statement, it will end everything, ends the while loop and ends the function. And if not, you continue to run. And okay, so you have this. It's going to narrow down the while loop, like to like gradually stop the while loop from running infinitely. Like For example, if I have A is 1, when I got A is 1, oh, sorry, I got A is 2, I will run to this and uh, like before running to this, still check the condition. Like obviously it's greater than 0, and then run through of the body of the loop, and then you hit the A minus equal to 1, and then you say, okay, A is 1. So check the condition again to see, oh, A is greater than 0. Is it true? Is it true? Yes, it is true. So you still run this. And then you run until you get the third time, eventually you get A equals 0. Uh, I think the second time, but you check the condition for the third time. It is not. It is 0. It is great. It is not greater than 0. It's equal. So you just execute the while loop. Yeah. So, oh my. So it's like you run to the counter and then you check the condition to see if the loop still can run. Um, you should have the modification. You should have to narrow down the while loop to change the condition. Otherwise, you will run into an infinite loop and you will burn down, like destroy all the program. It's an error. Yeah, I'll talk about it later. So if you check to see, to determine if the loop can still run under a new condition. So if yes, still run. If not, exit the loop. Skip the whole while loop, and then you go to the remaining part of the body. And then if you hit the return statement, just return and end the function. Yeah, so I check. If A is greater than 0 and the condition returns true, like return the true field value, continue in the loop. It's like a green line. Yeah. And if not, returns false. And you end the loop and go to the remaining part of the body. Yeah. So you exit the loop, it's like a stop sign. Like whenever how many miles running, like 100 mph or 1 mph, you have to stop. Yeah. Okay. All right. So here's a model of how while loop runs. So I have the input inside a while to check the condition, approve. Oh, I will run the loop. Run the loop, the codes inside the loop. And again, I check if it's still approved. If it's approved, I'll still run to run it again. And I had to check it again to see if it's okay. Like after many times, if it's approved for like maybe 1,000 times, and then for the 1,001st time, you get refused, rejected. So you stop going into the loop. You go to the remaining part of the function, and then if you hit the return statement, you have the output. And another case, if you have a return statement in the while loop, when it was kind of running something, you just stop the loop, stop the function. They're doing the same. They are doing it together, and then you return the output of the function. Okay. So, any questions about this? Yeah, about the how while loop works. Okay. So let's see. Turn off. Okay. So will iteration open a new frame? No, not at all. Like, why is that? Because iteration itself does not call a function. Like unless you have a function call inside the inside while loop or in the condition part, like maybe you have a function call and then you open a new frame. And if not, if you don't have a function call inside while loop, it will not open a new frame. Yeah. So in the env diagram, the relative variable will be modified again and again, and to try the condition, following in the while condition. You can think it's assigning values or to the same variable. Like um, when you modify the variable inside the while loop, because the while loop will run again and again until uh, it cannot satisfy with the condition or it will hit the return statement. But for some variables inside, it's actually kind of if you assign a variable in the while loop, it will assign again and again. So you can treat it as a reassigning values to the same variable. Yeah. So the loop itself does not store and or return values because the loop is actually usually inside a function. Later that on, we will talk about recursion. Recursion is pretty much the same as the iteration, but recursion does store and return values. So if you carry a value, like what carries a value, an environment carries a value, um, carries carries values, and uh, so the iteration itself does not have to store return the values because it's still like inside the frame. Yeah, we have a demonstration of it. So for example, I have to find 9. Okay, so I get here I'm going to do the while loop. So a is n minus 1, a is 8. So while a is greater than 0. So if a mod n mod a is equal to 0, which means that when you divide n by a, does it have a remainder? Or if you don't have the remainder, uh, if you don't have the remainder, the condition will return false from here because is it equal to 0? If not, so just skip an a minus 1. So you get 7. And you see how values change here. So we have a equals 7, and then we have 6. We have 5, then 4. Yeah, until you have 3. So here's a key point. Like you have 3, and then if 9 mod 3, it's actually 9 can be divided by 3, and there's no remainder, it's just 3. So it just return 3. Yeah. So 3. So for y, find negative 10. This is actually when you can go inside the while loop, you skip the whole while loop. Yeah. So you skip because it does not satisfy the condition, just skip the while loop. So yeah, and then just return 1. So here is like when you return, although I don't check the condition, it still return because you hit it still end the loop because you hit the return statement and you end the function. So return 3 and then you skip off them. Yeah, you end the function, end the loop. And okay, so the function here is actually finding the greatest factor of a number. So the greatest factor of 9 is 3. So I don't think I made an issue here, so it's correct. So the greatest factor apart from 9 itself. So I guess I can run this. So I have a function find here. So um, okay, so the function is like find the greatest factor of n apart from. So when you have let's say find 100 is should be 50. Yep, 50. And want to find 40, 20 maybe? 20. Yeah. So find 35. 7. Okay. So this is how it works. Yeah. Okay, so any questions about this? Okay, so then be careful of the runtime error. Like the runtime error is raised when the iteration cannot end. Um, it's basically you're having an infinite loop. So the cause of infinite loop is like two things. While condition is always true, or maybe programmers forget to narrow down the counter. Actually, the second arrow is the same as the first arrow, but sometimes you may see there are some people who actually want to make it as an infinite loop um, purposely. So they want to have the loop forever, forever. This is just like you may have some problems like that, not in my class, but in the future. Yeah. And then the while condition is always true, like basically just while true. So you can change it. Like you can use something, can create a variable to compare to it because it's actually just true. Maybe 2 minus 1 is equal to 1 is also true. So you run again. Mm. The second one is programmers forget to narrow down the counter. So while n is greater than 0, oh, so I have n float divide 10 and mod 2 and then solution, okay? But that's it. Like if if I say if I say n is equal to 1 and oh, I run into this and I compare with it. Oh, n still equals to 1. So I'll just run there again and again because I don't actually modify the variable n, the counter of this while loop. I don't actually, I didn't modify, so you run again and again. So the only thing we can stop it is like to modify n. You can either n, let's say n minus equal to 1 if it's decreasing, like I think it's decreasing, or maybe n mod 10. Yeah, like maybe there are other solutions, but like I have two examples of it, like to narrow down the counter. Okay, so any questions about uh, infinite loop. Yeah, good. Okay, so iteration and making decisions combined. Here's a combination of iteration and if statements. We have a very famous one called as conjecture. Uh, the logic is like if a number n is even, so n will be half of it. Yeah, and else if it's odd, so it will be 3n plus 1. So this is how the logic is. Usually, when you have the number greater than 1, it will end up with 1 eventually. So, so if I just do the range when x is greater than 1, and if it's even, like n x mod 2, like even number mod 2 do not have remainder, and I will do divided 4 divided by 2, or else I will get 3 times x minus plus 1 because there's only even or odd number, so you don't actually have something between it. So we can do example of this. It will print out all the results of a variable, like how many steps it went through and how many steps it will actually come out with the number. Okay, so I will have call let's say 16. Okay, I think that makes sense. Like 16 is even, so in mod float divide 2 is 8, and in float divide 2 is 4. Like they are both even, so they are float divide by 2. And 2 is also even, so float divide by 2 and it's 1. So when while x is greater than 1, it ends. Yeah. So that makes sense. Maybe I have an even number or not odd number. Call let's 35. Maybe a long story though. Okay, so it's odd. So if times 3 plus 1 become an even number, so 106 divided by 2, 53, okay, is odd. So times 3 plus 1. Yeah. And then 60, 80, 40, continue divided by 2, because they're all even number until hit 5. Okay, times 3 plus 1, since it's even. Oh, since it's not odd. So 16, still continue A, 4, 2, they are all even until we hit 1. Yeah. So this is one of the famous examples of it. Um, yeah. And some tips about solving iteration problems. Like there are 3 steps. First is to see if there are some special cases you want to modify on, like you have to modify your solution or maybe your variable. Um, it's like um, under what situations do I have to modify my data or modify my variable, my solution? Like, um, for example, I want to modify odd numbers. So if something is odd, I will make a change to it, and otherwise I will not change it. I keep it the same. And once you know what kind of situations you want to modify your solution, and then you think about how to make changes to variables, how to modify your solution so that you can go approaching to the solution you want, and for every time the loop runs, like it will modify the solution again and again. You may want to figure out um, what kind of algorithms, what kind of solutions you have to use um, to modify the data uh, every time, like step by step, or maybe accumulatively. And finally, how you limit the while loop is usually according to how you build your solution. Like, for example, if I want to list all the odd numbers from 0 to 100, and um, yeah, you may say, oh, okay, let's start from 101. So you check if it's odd and even number. Like if I want to list all the odd numbers, okay, 101 is an odd, so it will print it out and -2. So this is how, when you do -2 and you set conditions like x is greater than 0 because of the range, and you say, yeah, let's say that's when you want to find an odd number from 0 to 100, and you start from 101. So you have the while. The condition is like greater than x greater than 0, I think. And then you will check if that's an even or odd number. You may have an if the stuff is like kind of even number, you would say I will print this, or maybe, yeah, you may check it. Or um if you know like if you start from an odd number, you may not have to check it. Like, let's see, um while 0 x equals to 0, and then find, let's start from 100 this time. Yeah, let's start from 100 this time. We may say, okay, I have to check if it's even. So I will print this. How do I narrow it down? And okay, next time I know to find the even number, I have to be 98. You may get like x plus equal minus equal to 1 or maybe 2. It's okay. Like, but it's like example of how you narrow it down. Mhm. Like you go next time and you see, okay, and to check is this even print, and then you just still narrow it down um, according to your solution, according to how you build your solution. Like let's say you start from 100. If you start from 100, um, you may not have to check. You have to check this, but if you start from 101, you may not have to check this, but you still have to narrow it down like every time like -2. Yeah. Okay. Any questions about this? Mhm. Okay. So here's a practice. To reverse the input number and remove all even numbers. Let's have oh, let's have 15 minutes to do this. Using my methods here to see some special cases you want to make change to your variable the first time, the first step. Mm, yeah, and then how you build up a solution, how to make changes accumulatively, and the third thing is like how to narrow down the while loop while you build up your solution. Yeah. So the hint of it is like you get this like 123 mod 10, you get the last digit, and 123 floor 10, you get every digit except for the last digit. And this is how you check if there's even an odd number. And the input is 1, 2, 3, 4, 5, 6. You want to reverse the input numbers, like say from 6 to 1, 6, 5, 4, 3, 2, 1. You then remove all even numbers. We don't have this. We don't have this. We don't have this. So it's 5, 3, 1. So you can do these two steps simultaneously at the same time, and maybe you can do it like I suggest you do this simultaneously, and let's have 15 minutes to do that. Yeah, how you um how you know when you got to make change to the solution? Like I return the solution. I already built up the variable for you. How you return the solution? Uh, no, how you modify your solution? Like under what cases, under what situation you want to modify your variable, and then how to change your how to modify your variable, and then how to narrow it down. Yeah. Okay. Let's have let's have 15 minutes to do this. If you're finished, just type one. Yeah, you can either type it on maybe online Python interpreter in your Visual Studio Code, or maybe on paper. Yeah, but I do suggest you have a pen and a sketch paper, or maybe an iPad to show how you actually solve it. Like how's your logic and um. Mhm. Usually when you want to solve problems like that, uh, you have to do with a sketch paper. We have 4 minutes left. 1 minute left. Okay, so let's get started. For this problem, mm, I don't know how you guys are doing. How are you doing? It's actually okay. Um, okay. So reverse the input numbers and remove all even numbers. Um, so the first step we're gonna do is to find um, under what situations should we modify our variables. So remove all even numbers is basically means like when I'm doing the modification uh and I check that like okay, the last one, the last digit, if the last digit is even, I would not do like I will not keep the digit in. And if the last digit is odd, I will keep the digit. So which means that like we're saying like remember how we say like if else statement is necessary. In this case, else statement is not necessary because we don't have to modify even. So like when we have the last digit is odd, so just keep odd, keep that digit, and we can ignore the last digit if the last digit is even. So let's see. So that's some like involving if statement is that kind of like solution is doing some modification. And how is that like how can we find if a digit is an odd number? So remember we have 5 mod 2 should be 1. So something mod 2 should be 1. And how can we get the last digit? The last digit is like we have here. We have 103 mod 10. Oh, sorry. So it didn't get the last digit. When you do mod, so 103 mod 10, you get the last digit 3. So you see, I pass in x, so should be x, uh, so be x mod 10 here, and then mod 2. So that means it is on. And the next thing is how we modify our data. So let's do the input is 1, 2, 3, 4, 5, 6. Output is 3, 5, 3, 1. So you get this number here, and you check if the next one is even or odd. Yeah, so it is even, which means that we do not take this into account. And then how we get the last 2 digit 5? How we get this digit? So we will do 4 divided by 10. Like remember 4 divided by 10 is 1, 2, 3, 4 divided by 10. should get everything apart from the last digit. So you get 12 for here. So if 4 divided by 10, we get 1, 2, 3, 4, 5. And then we check if that's even now. Oh, so it's odd. So we got to modify this. So you can solution. The first step is like solution can be 5. You may want to think, oh, I have to times 100 or something, like because for our output is in the 100th like times 100 and then gets the stuff behind him. But don't worry, we can get it through later though. So now that we get solution is 5 or maybe 5 times 10 to the some power, and then we continue on. Um, and then we mod 10, still mod 10, again, 1, 2, 3, 4. So it's even. Don't take it. So mod 10, 1, 2, 3. So I guess solution is kind of like 5 and 3. And I want to get 53 instead of like maybe 50 times 10 to something. Um, so I still have 5, 3. So what should I do? For here, we have solution is 5. 5 means that if only I times 10 to itself, and then add the number I want to, so then I'll get solution. So that I'll get a new solution, 53, or maybe 53 times 10 to something power, and still get like 40y is 2, don't take it, and still get 1. And the solution is kind of like I have 53 and 1. So I will still, as usual, I will still times solution times 10 plus 1. So I get the output. Yeah. So how to narrow it down? How to narrow it down? So narrow it down is that like we just modify the variable by floor dividing it by 10 every time. So we'll take this into account. And how we build the solution though? Solution is like solution equals solution times 10 and plus maybe x mod 10, kind of like this. Does it make sense? Like for the first case, remember that oh wait, the solution is 0 for the first step. Uh, I built it up already and it's assigned to 0. So for the first thing, solution, can solution be solution times 10 plus 5? Yes, it can, because solution is like 0. 0 times 10 should be 0. So plus 5 is 5, which makes sense. And for the second one, still solution times 10 plus the last digit, and then solution is 5. Solution is 53 and 1, and I still times 10 to it, and then plus the last digit. And then I get 1, but 1 mod 10, what should 1 mod 10 equals to? So should be 0, because when you do 1 mod 10 should be 0, it is 0, so you get 0. But for at this time, the while loop should end loop. Yeah, so this is how I got it. Yeah, so for here, how I wrote this down. How I wrote this down. Mhm. So I have, like, for convenience, I will get like A is equal to X mod 2. So if A, oh wait, X mod 10. Mhm. if A mod 2 is equal to 1, which means it's odd. So that means I get solution equals solution times 10 and plus the last digit. I think just A. Yeah. And then how we narrow it down? X equals X 4 divided by 10. For syntax, I may have indentation error. So just say, yeah. So the base case, the condition of it is S greater than 0. This is how I got. Like maybe you got the same, maybe you got something different, but as long as it works, it's good. It's a good solution. So let's try the answer. So you get the function call, and then you pass into it, and then you get solution is 0. And then while x is greater than 0, yes, it's greater than 0. So I'll get n equals n mod 10. So n mod 10 is 6. I get the last digit of a bunch of the numbers. So I get if I check if the last digit is odd. It is not odd, so I've skipped them. I'll keep narrowing it down, narrowing the narrowing the x down. So I still check y is greater than 0. Maybe. So yes. So it's greater than 0. So still get the last digit. So it's 5. I change it to 5. So it's odd. So I get solution. Solution should be 5 this time. So mod 10 again. So I deleted 5 from x. Again, I get n is x mod 10. So last digit is 4, and 4 is even. So I will abandon it. Get x equals x 4 divided by 10. Remove 4. So and then x is greater than 1, greater than 0. So still getting it and get last digit 3. It is odd. So at this time, I will times solution times 10 to the solution, and then I will add the last digit, becomes 53. Okay, again, remove 3 from the original data, the input, so I get 12. So I get 2 is even, skip, and again, you eventually get 1. So I still times solution by 10, and then get 1 plus 1 at the end. So I get 531. And then I mod it. I divide by it until it gets 0. So it's time to end the loop and return. Yeah. Okay. This is how it gets. Any questions about this? Yeah. Okay. So I get 531. What if I get 135? So the practice too. We don't have to go through that. But if you're interested, you can just scroll through. There are 2 answers there. You can check it. For a common answer is that I get 531. So how I get 135? Again, I use the same algorithm. That you get a mod a a equals to x mod 10. You get last digit, and then you still get solution 2 equals solution 2 times 10 plus a. So through this step, you reverse 531 again, so you become 135. You may have 2 while loop, but I also have a answer 2 does not have while loop, so you can check it. Usually, the fewer while loop you have, the more efficient your program will be. Okay, I think that's it for today. Thank you for coming. Hope you have a very nice weekend. Hope you have all the good luck with you. And I think that's it for this week. Yeah. Uh, Any questions, final questions about it? In the law. Okay, all right. Thank you for supporting me. Yeah, kind of. Yes, some places I can't get some redundant, and I can explain things very well. I don't think I prepared it very well because I only prepared how to explain something only about 70%. So yeah, thank you. Yeah, bye bye. Bye bye.